Welcome, everybody. We're going to be working on both the lab exercise and the assignment here tonight. Our goal is basically to code through these. As is pretty typical for when we're doing this, I'm going to read through the description and then we'll start building the code. It says, congratulations on your new job. You made 1 penny on the first day, 2 pennies on the second day, 4 pennies on the third day, and so on, doubling each day worked. Write a program that asks the user how many days they worked and outputs the total number of dollars and cents earned formatted as currency. Do not accept a number less than 1 for the number of days worked. Continually ask the user to try again until their input is valid. So we're going to do some user input validation here. And then for each day, output the number of pennies earned. Now, I don't know if you guys have ever done this algorithm before, right? Like you get a penny and you double it each day. Like, how long does it take to be a millionaire? Has anybody ever done that one? Okay. Well, we're going to find out, by the way. It's pretty interesting. Like, if you could really earn interest like that, where your money doubles every day, that would be quite a thing. All right. So, for the lab, we are going to basically mimic this sample program run. So we're going to have a little title, so we're going to say salary calculator. So we're going to put that on the screen. Then we're going to prompt, right? And this is invalid. This is invalid. Notice the error message, right? And then when they start putting in a valid number like 8, right? It shows the pennies earned on each day. Notice how they're doubling. And then at the end, we're going to output the total, right, which is the combined value of all those as a currency. So that's kind of our grand goal. Now, remember, our chapter is on looping. That's really kind of the main focus here. And when we did our lecture on this, we basically looked at 2 major loop types, right? The while loop, either in the pre-test approach, which is the more typical one, or the do while, which is post test, and the for loop. We didn't really touch upon the for each loop, which is kind of the automatic one, but basically 2 loop types, while loops and for loops. And we're going to use both of them in the solution here. Not that you must, but the program seems to lend itself pretty well to that. Now, whenever we're doing user validation, it makes a whole lot of sense to use a while loop to get the user to put in the correct information, right? And as long as they're not entering the right information, you keep asking them, right? You loop until the input is valid, right? So I'm giving you a little bit of a tip right there. So if you think about your problems in that capacity and verbalize them, and maybe you're not a person to say it out loud. I get in the habit of saying it out loud because I teach, right? But even if I wasn't teaching, I would be trying to say it in my head, because if I can think it, then I can probably code it, right? That's kind of how my brain works. I think it's really how most people's brains work, but I'm not going to enforce like my learning style upon you with that. I'm just kind of putting it out there. Now, we do have all the other techniques that we've learned in class. So if we wanted to write functions, we could do that, but I'm not going to do that. I'm just going to write a straight sequential program with some loops in it. And then if you wanted to, turn the different pieces of it into functions, you could, right? I'm just kind of stating that up front as well. Let's start by getting a basic program going here. So let's create a new project. Console app in C#. Let's pick the folder we want to work in, as opposed to the folder we're being coerced to work in. We're going to select this folder, and then I'm going to name this mod for lab. And was it salary calculator? Salary. I'll just call it salary calc. How about that? Go with the defaults on everything. We are not going to use top level statements for this, at least at this point. I will start to pepper that in once in a while here, just so you guys can see the usefulness of it. All right. So here's our program with all the default stuff in it. And I'm going to, of course, blow that away. You want to label it, I suppose you can say module for lab salary calculator. There we go. All right. First thing we want to do is, well, looking at the program run, what's the first thing that happens? Well, they put the little title up there. Let's make a title. All right. So I'm going to just flip back over here. I'll start with a comment and I'll say display the header. Okay, this is going to be a bunch of console write lines. Of course, I'm a huge fan of ASCII art. Maybe that's because of my age, but this is what I did, right? So I know the one that they show just, basically shows these two lines, right? Salary calculator with some under dashes underneath it. But I decided to put it above also. Why not? Let's make it look good. Right. And then I'm also outputting a blank line. Yeah, I could have done that more efficiently. I suppose I could just go \n, right? And I could get rid of that. Could I do this as all one line of output? Yeah, you could. Your choice. Sometimes when I'm doing stuff where I know it's going to be kind of ASCII art-ish, like it's like console art basically. I like to do the right lines separately so I can see what it's going to look like here before it gets there. Right, so that's displaying the header. Next thing we need to do, and I'm going to look at the instructions again. Oh, we need to prompt the user to enter the number of days worked. Okay. Now, if you recall from our lecture materials, my goal here is to validate the user input using a while loop. I've already alluded to this. And if you remember from the lecture that when we're prompting the user for information and we want that loop to run or not run, we usually do what we call a priming read, right? So we prime the code by getting the input before the loop even gets there. So I'm going to just say get input from the user and check for validity following the step. So that'll come in the loop below. But let's do the prompt. So I think it says enter the number of days worked. So I'm just going to paste that in there. So console write on that so it stays in the same line. And then we want to store that information. Okay, so what are they asking us for? The number of days. So I'm going to create an int called days. Seems to make sense. We're going to do a console read line, but we're going to convert it to an integer. So let's just get all that syntax in there. So we'll say convert to int32. See how it's recommending exactly the right code? How do you capture that code? I hit tab. And again. Right. I don't know if you guys have figured that part out, but yeah, the tab key is kind of the magic key there. All right. So we've captured the information now. All right. Now we're going to run the loop. Check if input is valid. And if not, ask again. Right. Basically, badger them until they get it right. All right. The while loop is what we're going to use here. So I'm going to start with while. Now I got to think of the logic. What is the logic here? We're looking for stuff that's wrong, right?
If probably the days is less than one.
Yeah, I like that, Anthony. That's a good answer because if they don't work, well, they're not earning any pennies, so that's not valid. They're going to work at least one day. If you put in a negative number, that's not valid. So it has to be one or above. So while the days are less than one, so this is the invalid condition, right? This is what we're checking for. So it's kind of like an if statement too, right? If they enter the number 1 or above, this while loop will never happen. Right. So that's put in your head. So now what are we going to prompt them to say? Well, first we should give them an error message, right? There's my error message. You can say whatever you want for the error, just as long as they're aware, right? And then we're just going to use the same statement from above as input, but we don't need to redeclare days. We have to remove that int thing from in front of days, right? We'll just prompt them, convert it, store it. So this will get populated. It comes back up. It gets checked again. And if they finally do it right, then we move on. But they will get continuously prompted until they enter it correctly. Right. This, and I should probably put this as a note, the priming read of the data, right? Before we go into the loop, we're priming the loop to see if it's going to run or not, right? If they fail the test, or actually if they meet the test, which is the failure option, basically, we give them an error and we ask them to try again. Okay. Next thing that we're going to do is we're going to process the output, or maybe it's better to say process the amount of pennies earned. Okay. Now we need to think about this a little bit, right? First thing you should think is, what pieces of information are we working with? What are we trying to keep track of? We have to keep track of the days. That's already done, right? Well, let's look at the output as an example, which is we're kind of tracking, we're counting the days, I guess. We are counting the number of pennies. And then we are going to total the number of pennies. So I'm seeing it as like, well, days we have already. I think we need a variable for pennies, and I think we need a variable for the total, right? So now, because we're dealing with monetary amounts, right? And it becomes kind of standard, by the way, that when you're dealing with monetary amounts, you should choose double as your data type, right? It's kind of an automatic for programmers, by the way. I guess I'll create a variable for total, and I'm going to preset it to 0. Seems to make sense. We'll create another one, and this one we'll call pennies, and we'll preset this to 0. You see how I'm pausing here and like smirking a little bit, right? Well, no. We don't want to set it to 0, because 0 is an invalid entry, right? We want 1 or more. And no matter how many days they type in, right? So if they type in a number of 1 or more, at the worst case scenario, they're starting with 1 penny. Right. And this is a piece you guys might miss. Some people might set this to 0. Okay. Now we are going to loop and generate this content. So like, how do I know that I need to loop to generate the next content? Well, because it's repeating, right? The first part of it, this is always repeating. This just seems to be a count up. And then this is this the current total, or is this the number of pennies per day, etc.? So these are the things. I think the total doesn't seem to display until here, but the number of pennies and the day certainly display, and then there is repetition. So a loop is the logical tool, but this time we're going to switch over to a for loop. So I'm just going to say loop and generate the repeating output. All right. I've already decided it's going to be a for loop. And why am I going with a for loop? Because now this might seem like it's indeterminate, but the moment the person types in the number of days, I have a finite run length for my loop, if you want to think of it that way. It's a finite amount of iterations that the user has just declared by nature of their valid input. So if they type in 8, it's known. So I can use a for loop because the amount of iterations is known. All right. One thing that we haven't talked about is, okay, so often when we're doing looping, I'm going to hit tab and accept the int I equals 0. Why do we use I for loops? Right. And here's the answer, by the way. This comes from mathematics, right? I implies index value, right? And this is really kind of goofy, but if you learn calculus and most of you are like, no, thank you, right? That's how you feel about it. But I'm going to tell you what, when you learn how to program and then you learn calculus, the calculus stuff totally makes sense, because what calculus notation does is they say the same kind of thing we say about a for loop, and they just do it with really crazy looking characters, and they'll use like these weird sub numbers. So for example, I'm just going to kind of very quickly annotate on the screen here. Like for example, like in calculus, we might use the sigma character, and then we'll use these little like characters down here, like n equals 0 and I equals 1 or something like that. And then they'll have like this crazy formula that follows. And then really what the notation ends up meaning is we are developing a sum over a range of functions, right? That notation that you just saw with the sigma, which is like a loop generating a total from variables being pumped into it. And this is really fascinating because direct correlation to looping and programming, right? So you should never be afraid of calculus. It's just a different way of saying the same thing, right? So really what we're doing here is kind of a calculus equation, right? So you can tell your mom, hey, mom, I learned some calculus tonight. I'm sure that's what you're going to do. All right. But the reason we use I is because in calculus notation, for whatever reason, somebody said, well, if we're iterating and we're basically like indexing each iteration or counting it, let's use the letter I. And then if we're doing a loop inside a loop, then the next loop should use the letter J. That's really common in programming. So if you ever wonder why they're using I and J in loops, that's why. It comes from that. All right. So that's our loop control variable. That's the one that's going to kind of monitor the running of the loop that we're going to use to count up. And notice, this is crazy how intelligent Visual Studio is now, because the code that it's suggesting is exactly the right code to type to solve this problem, right? So we are going to use I. We're going to check to make sure that it's less than days. So in other words, how long are we running a loop? Well, the counter is starting at 0, but we have 1 penny. So if the counter started at 1, I would say I is less than or equal to days, right? But I'm going to say days, right? So the user controls the number of days. That's what makes it finite, even though we don't know what it is going in, but the user controls it, basically. And then every time we go through, we have to increment. So we'll just go with the I++. That's correct. Right? Curly's?
Can we use like I equals plus 1?
Anthony, you're asking, could I do this?
Yeah.
Yeah. Serious programmers would laugh at you, but I'm totally kidding. Anthony, it would work just fine. The convention, and why that plus plus operator is even thrown in this module is because it's used so much in looping. It's one of the reasons it was even designed. But yeah, any valid programming statement can sit inside here It doesn't have to be add 1. It could be add 20, right? And plus equals works just fine because, think about it. If I'm, this is the same as saying plus equals 1, but if my actual intent is to plus equals 5, I can't do it with a plus plus, right? So that's kind of the why. All right. So what's going to happen every time the loop runs? Okay, well, let's look at the output. It's going to put these words on the screen, right? And this other stuff. Okay, so here's how I did that. So back over to Visual Studio. So I just did a console write line. I am using string interpolation, right? That's the $sign there. I'm just saying pennies earned on day. And notice what I had to do here, because this is starting at 0. So I have to say I need to make that a 1. So whatever that value is, I add 1 to it. Yes, I could fix this problem by starting at 1 and making this less than or equal to. That would work too. So if you did it that way, you're good. Both sets of logic are correct. Then we're outputting a colon, and then we're outputting pennies, which is, okay, well, on day 1, pennies is 1. So that's right. Right. But now we have to think about what are the other actions that are happening here. Well, the first thing is whatever pennies we have currently, we are going to add that to our total. So we're going to say total plus equals pennies. We're going to take those pennies and put them in the bank or whatever. Right. Then the number of pennies that we're earning is going to double. So I could do it 2 ways. So I could go pennies times 2. That would work. Or if you guys want to try a challenging thing, it's not really challenging. Like how we do plus equals, you can also do multiply equals 2. So I can take pennies, multiply it by 2, and stir it back in pennies. That's the shortcut command for it. Isn't that slick? I like that. Yeah, I think that is pretty slick. And if it helps your brain, right, to understand the difference or remember what this even means, you could just, make a little note, pennies times equal 2 is the same as pennies equals pennies times 2. Same thing. All right, so that's the pennies. All right. This is outputting each one of those statements, right? So we're going to pennies on this day, adding to the total, we're doubling it. I think this probably will work just fine. We'll see when we run it, of course. But then we also need to put that total up on the screen, right? So that's just going to be a write line, but I do want to put in a comment here. So we're just going to say display the results to the user, right? Like what's your total, basically. So you can do that with a very simple little output statement like this. Here's the question, because you guys might not see this right away. Why am I dividing by 100?
There's 100 pennies in a dollar.
Yeah, that exactly right. So otherwise, I'd get the total number of pennies, and I'd format it as currency, and instead of like $100, I'd have $1,000, but which isn't correct. Right. So I'm just dividing by 100 to scale it, basically to move the decimal point over 2 to the left. That's what we're really doing. All right. And then this is really kind of goofy extra code you don't need, but might be cool to add anyhow. All right. So this is just me like kind of resurrecting some of my old school programming like stuff. Like when you run a console program, instead of having like Visual Studio already put up its message, it says, hit any key to continue. I can generate my own message that says that. Right. Notice all the line breaks in there, right? Lots of space, lots and lots of space. All right, let's try to run this and see what happens now. I'm not getting any underlines, not green ones, not red ones, so my code must be okay. So here comes the run. All right. Pretty fancy header, don't you think? Yeah. Enter the number of days worked. All right, let's try some invalid entries. -2. 0. Oh, I really tried to break it. So we don't have something to accommodate for text entry, do we? Right. I'm going to hit continue. Try it again. Right. So we'll learn how to do that later, right? But for right now, we're hoping that they type numbers. And I would argue, right, like if you're writing a good program, you should tell the people using the program, please enter accounting number. You should say it, right? I'm not doing it, but you should. I'll put in a valid number. And there we go. All right, well, let's kind of expand the whole window there and take a look at the whole thing. Did it tabulate correctly? Well, it matches what we have in the sample run, right? So that's doing 8 days. So in 8 days, I earned 255. All right, let's play with it a little bit, right? If you guys aren't feeling where I'm going with this, let's enter a significantly larger number, right? How about 123 days? It doesn't take very long, right? And how much are we earning at the end? Well, after 123 days, if you double, so if somebody ever gave you the offer, hey, I'll pay you a penny a day and every day I'll double it, you say yes. You say yes to that. And can you see why? After 100 days, I mean, that's thousands, millions, billions, trillions, quadrillions, yada, 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 yada. Donald Trump federal debt is nothing compared to this number, right?
I invested a penny in Bitcoin. That's my total today.
Right. If only, right?
Right.
if only. But I think that's pretty interesting. So really, to clear $1 million, I think it's like 30 days. In 1 month, you'd have $1 million by doubling your pennies every day. Yeah, I mean, that's astounding, right? I think it is. I think it's really also kind of fun to see what happens when we start to exceed the bounds of an integer and a double that's storing the values. What happens on day 58? Notice that it switches to what we call exponential notation. So this is the same as saying 1 point whatever this is times 10 to the 17th power, meaning 17 decimal places, right? That's what this expression means. But notice C#'s not joking on it. It takes it, it runs with it. It just keeps adding to it. So it works, right? Okay, so that's our lab. Now, quick question for everybody. Everybody get it to work?
Yes.
No problems. All right, fantastic.
Just some syntax issues, but I fixed it.
Okay. Oh, good. I'm glad to hear that. All right. Let's now I'm going to go ahead and close this solution and we'll make a new one. That went pretty quick, didn't it?
Mm-hmm.
Yeah. Now you guys are thankful that I did all that lecturing the other day, right? Especially if you're goal is to watch Thursday night football. I'm just saying. I'm not even sure who's playing tonight. Does anybody know who's playing tonight?
Eagles and the Commanders.
Okay. Not sure who to root for there. None of the above, I think, is the answer. All right. Before I go naming our assignment, what I'd like to do is let's read it to make sure we're doing it correctly. So I got to click through a couple screens here. All right. So here's the assignment. Write a program to count the number of even and odd numbers from a series of numbers whose starting and ending number is provided by the user. The starting number must be less than the ending number. The program should continue asking the user for valid ending number until it is larger than the starting number. The range is inclusive. The starting and ending numbers should be tested and counted as part of the series. Okay, so this is kind of a weird one. Like you could read this a few times, right? And now I didn't write out this assignment, so I might choose a different wording on it. You have to really read this carefully to understand it, right? So I think that's a really important thing. And that really kind of goes back to this fundamental aspect we learned right at the beginning. You can't code the right solution until you understand the problem. And I think that's like one of the most important parts of programming. Man, do you want to spend time writing a bunch of really complicated code only to find out that that's not what we wanted? And that happens in programming a lot, right? So getting that first part right is really important. All right, so let's look at, for example, what it should look like, right? So starting number 2, ending number 10. Okay, there were 5 even numbers and 4 odd numbers. What the hell are they talking about? Okay, so let me do this. I'm going to annotate the screen again, right? And that means I'm going to type on the screen, basically. And I know I'm using a really ugly color here to do it with. Maybe we can actually use like black or blue or something like that. Okay, here we go. So in other words, starting number is 2, the ending number is 10. So I'd go 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. How many even numbers? 1, 2, 3, 4, 5. How many odd numbers? 2, 3, 4. That's really what we're doing, right? So, and once again, this is where like a picture and like a physical demonstration over a picture makes a whole lot more sense than the words we just read, right? I think so, right? And this is, since we were talking about math before, this is one of the problems with like learning programming and math. The part that people hate the most of math is like, oh man, a word problem. Ew, right? I know I used to think that way. It's like, oh my God, just give me an equation, please. I know how to do those. But it is a thing. And this is exactly what's meant by this, right? So this is what we're coding, right? So that's the example. And hopefully you find that helpful in terms of doing it. Now, here's also an example of the program running like incorrectly, right? So starting number of 5 and an ending number of 4. I can't count from 5 to 4. I also can't count from 5 to 5, but I can count from 5 to 6. If I go from 5 to 6 and create a sequence, I have one even number and one odd number. So once again, there's input validation happening here to basically, what are we checking? Think about this. To check that the second number is greater than, or, well, I don't know what happens. Well, equal doesn't work. It has to be greater than the starting number. Simple as that. Can't be greater than or equal. It has to be greater. Okay. So I think that helps to explain it pretty clearly. So what do we call this one? What's the exercise called? Assignment. Okay. Got it. So we'll just call it mod 4 assignment. Mod 4 assignment. Right. And maybe, you could say number series, even, odd, if that helps you, right? You can name it any way you want. So I'm going to go with that. And then we're going to run this. Right, maybe label it for assignment. You can say any other stuff you want. I'm not going to be commenting this one out like I did the previous one, right? You know, I do that often when I'm teaching to kind of like reinforce concepts. And what I hope that you guys get into as you're coding is you do it for yourself. You know, if it helps you, like some people like feel like, I don't know, I don't need that. I know what I'm doing, right? Fine, great, good for you, right? But if you at all think you're going to forget why you're doing something, you should comment it, right? It doesn't harm the code. It doesn't change the output of the code. And this is really kind of an interesting thought. When I add comments to code and then I compile it and run it, it turns into an exe file, executable. Those comments are not in the executable. They're only in the original source code. The executable omits it. The executable travels only with what it needs. All right, so I think that's kind of an interesting little aspect. All right, so let's prompt, and I think that their first prompt is basically asking for a starting number. Notice I'm also creating a variable called start. You want to call it starting num, whatever you want to call it. I'm just calling it start. Right. Converting it to an int, et cetera, et cetera. That's pretty normal stuff. And hey, if we're doing a starting number, let's do an ending number. So I'm just going to copy all of it, right? And then I'm just going to change this to end and ending number. I think that works. No reason to make it any more complicated than that. Okay, now we have the challenge here. Once again, we need to validate that what they just typed for the second number, the first number doesn't matter. As long as it's a valid number, it can be any starting number we want. Does it matter if it's negative or positive? Here's another question.
I think it does.
Okay, Anthony, why do you think it does? The fact that you're struggling for an answer tells you that it doesn't matter, by the way, because you're searching for a reason. Actually, this is what's going on in your brain, right? It doesn't matter. Like if I start at -10 and then I put in -2 as the ending number, that should be fine too.
Because it's higher than -10.
Yeah, exactly. It doesn't matter where on the, for what side of zero we're on. It doesn't matter at all. Right. All right. So I'm going to do the while loop, and oh my God, you know, Visual Studio, impressive with its autocomplete. Not quite the statement I was going to type, but okay, let's think about this. What is the error state that we're looking for in order to have them re-enter the ending number? Is what it's suggesting correct?
No, I say no because the end, wait, the start is greater than start is greater than.
Yeah, and I like that you're thinking out loud, Anthony. You know,
I'm sorry.
I say this sincerely. I know it's like people are like, oh no, I'm talking to myself. You know, I'm going batty or something. But no. Sometimes, real frankly, saying it out loud makes your brain think about it better. So if that really helps you, you do that. Right?
The end needs to be greater than the starting number. So
right.
That's wrong.
But how about if the end is less than the start?
So it's the same.
It's the same. Yeah. You know, so the point is I could express it this way, or in the way that I did it last year when I did this, I think I did it the other way around. I said, while the end is less than or equal to start, isn't that functionally the same? This is where you got to like stop and think for a second. Does that saying the same thing? So if end is less than or equal to start, because we did have that stipulation, because if the two numbers are the same, that's an issue too.
Mhm.
So could I do it like this, or oops, control Y that, or would this work? All right, I'm going to let you ponder that a little bit, but the answer is basically either way would work. As long as your logic is sound. The equals is important here, you know. I'm going to do it the way that I did it last year just because it makes me feel more comfortable. Real frankly, you know, that's the only reason, right? Because I know this worked, basically. And then let's put in our curlies here. All right. All right. So this is the error state that we're checking for. So if it's an error, the number is either the same or less. The ending number is the same or less than the starting number. It's no good. We need to prompt again. So we want to give them an error. Notice the repeat from the lab. Give them the error. And then prompt them again. So we'll copy these two lines. We will make sure that we remove this though, right? We don't need to redeclare it, but we are going to prompt them again. Yeah, and we'll leave the prompts really simple. You could get snarky with your prompts and say, you know, and I'm, you know, maybe I had too much Starbucks today or something, but you know, I'm thinking like, and enter an ending number that's correct. You know, like it's just something goofy like that, right? Now, you know, the kind of personality you want to put across in your programs, you know, you know, is reflective. Have you guys ever used a piece of software where you get like error messages that are kind of clever or snarky like that? I always get a kick out of it. Like they're waiting for that one person to make a really big goof so they can kind of point out the fact that, hey, you made a really big goof and we caught you on it. Right. All right. All right. So now we have, assuming this works, we have valid starting and ending numbers. What other stipulation do we have to consider here?
Do we have to consider what we were talking about previously about negative numbers at all?
Well, no, Anthony, I think we ruled that out because I could put in a -10 and then I could put in a -5 and the formula is still valid. Makes us uncomfortable, right? But the formula is still valid. All right. We're going to need, here's the part maybe we're missing. We're going to need to count the number of evens and odds, right? So why don't I set up an even and start counting at 0? And on the same line, I'll declare odd, set that to 0 too. So two integer variables that are going to keep track of the number of evens and odds. And once again, I'm going to go into a for loop this time. So we're practicing both loop types. Could you do this with a while loop? Yeah, you could. But I like to practice the for loop as much as I can. Once again, because we are gathering valid input from the user for starting and ending, this for loop that we write will work just fine. So we can use a for loop because it's finite in a way, right? All right. But once again, blowing me away at how accurate the auto suggesting IntelliSense is here, right? So this is exactly what I would type, at least for the first statement. So I'm gonna hit tab and accept it and say to myself, so if I'm running a for loop, where do I want to start? starting with the starting number makes sense. Okay. And then I want to run that until it is less. Well, we're going to run it as long as it's less than or equal to the ending number. And then are we going to increment? Oh yeah, we have to increment the I for sure. Right. Now we got to get the logic in there. Once again, it's auto suggesting and it's scaring me a little bit, right? But how do we determine if something is even or odd using math?
The modulus.
Yeah, we would, right. We divide, we'll
Mhm.
divide by 2. And if there's no remainder, it's even. If there is a remainder, it's odd. Simple as that, right? So here's the if statement. If I mod 2 is equivalent to 0, we are going to even plus plus. Else, yeah, odd plus plus. I can do it just like that. Now, normally I would move this down to the other line, but you can actually type it like this, on the same line if you want. Yeah, that's the whole logic there. Any other maneuvers I need to make? No. That's all of it. We're just counting them. The other maneuver we need to make is just to put it on the screen. Yeah, that's it. And we're done, folks. So here's the console right line for the even numbers. And of course, the odd numbers to follow. Okay, let's try it. Control S to save. All right. Of course, we start by trying to break it. All right. All right. So let's do. Actually, why don't we mimic what they do on the sample run? So they had 2 and 10. Okay, let's see if we can get the same output. 2, 10. 5 even, 4 odd. Looks good, right? Right, run it again. Once again, we'll do that same overlay. I think is kind of helpful. Right. So starting number 5, 4, 5, 6. Yes. Okay. So we're getting exactly the same output. I feel pretty good about it. But now let's test our negative number theory and see if that's valid. Okay. So back to Visual Studio here. Let's run again. So let's do, how about minus 12 and 5, a negative number and a positive. Yeah, no problem. Or how about a negative number and a negative number? But notice that the second number, yeah. So I'm just kind of proving that it works in any scenario. So we're good here. All right. So this is a valid solution, by the way. The one question I always ask when we do these assignments and exercises, and I know some of you work these in advance. I also know that my older videos are there, so you can look at the solutions in advance, but I give them anyhow. Did anybody write this on their own and come up with a completely different way on any of this stuff?
Yeah.
Okay. Well, Teresa, I'm not going to force you to put it in the video. So I'm going to pause the recording.